Okay, this is the subdivision problem for 2.4. The idea of this is to show that you can divide this area of land, which is divided by a pipeline. It's to show that you can break that up into 4 sections, each over 400 meters squared. For excellence, you have to show that you can break it up into 4 sections, each over 400 meters squared, but one of them has to not be a triangle. So we'll show you that at the end. But first of all, just the achieve skills. We want to make sure that we can find all these angles and the side we don't know before we move on. Firstly, that's because if you don't know these angles, you might not even know how to go about solving for the area. So we're not going to worry about area at all for a little while. First, we're just going to solve these angles. So we don't need the sine rule for area. So first of all, I'm going to break the triangle down into 2 parts. This is the first triangle we'll deal with, then we'll deal with this one here. So I've drawn just this triangle here, and now we just want to work out these angles and the side here, which is the pipeline. So if I call this angle A, and this one will be side A, this can be B, this can be side B, this can be C, and this can be side C. Now we can just use whichever rules we think we need. Now at the moment we've got 2 sides and an angle, but we don't have an angle with its opposite side. That means we can't use the sine rule, which leaves us only with one other option, the cosine rule. So a squared equals b squared plus c squared minus 2bc cosine of a. So that will be a squared equals 50 squared plus 40 squared minus 2 times 50 times 40 times cosine of angle 60. Make sure it's in degrees. When I've calculated that, I can type into my calculator. I'll do that. It'll give me 2100. That's not a, don't forget, that's a squared. So we want to take the answer and take the square root of the answer. That will give us a, which equals the square root of all of this, 45.83. We'll round to there, 45.83 meters. So I'll just put that in on my diagram, 45.83 meters. So that's the length of the pipeline, because this is the dotted line through the middle of the previous diagram. So we've worked out that there. That's part 1 of the question anyway. Now I want to work out both these other angles just to make the rest of the problem easier. So I'm going to do that now using the sine rule, because now I have an angle and its opposite side available. So I can use the sine rule. Sine of angle A divided by length A equals sine of angle B divided by length B. Now I know A, I know side A. I don't know B, but I do know side B. So I'm going to put in what I know. And I will rearrange so that sine B is by itself. Alright, so that's just some algebra there. I can type that into the calculator. Now that's not angle B, that's the sine of angle B. So to work backwards, I want to find sine inverse of all of this will equal B. So all I have to do is go sine inverse of what I worked out B equals 70.88 degrees. So I can put that in now for my B, and there's two options for working out angle C. The first option is to do the same process again, except I'll have sine A over A equals sine C over C. But the easiest option will just to be, I'll just go to one decimal place here, will be to make this the third angle to add up to 180 in a triangle. 49.1 degrees. Now we have all three angles, all three sides, and we can move on to triangle number 2. So just update our diagram. 70.9, 49.1, and this side, the length of the pipeline, was 45.83, and we'll need that for triangle 2 because it'll be the opposite side from this one. So here's triangle 2, which, as you can see, matches this triangle at the top. We're going to do the same thing. This time, however, we have no angles to start with, but we have three sides. Once again, we'll have to use the cosine rule. So I can say that if this is angle B, then this is side B. Angle C, then this is side C, and here's A. I want to work out angle A to start with. I know that A squared equals B squared plus C squared minus 2BC cosine of A. I know what A is. I know what B is. I know what C is. So I'm going to rearrange this equation first so that I've got cosine of A, because big A, the angle A, is what I don't know. So if I put this whole thing over to here, and this A squared over this side, that's going to leave me with 2BC cosine A and from there, one more step. You might be familiar with the cosine rule written in this format anyway. And if you can just remember how the cosine rule looks when you've got the angle by itself, then you don't need to remember the derivation, you can just write it out. So cosine A equals B squared plus C squared minus A squared divided by 2 times B times C. Right. In the calculator, that will give me that's the top row, divided by 2 times B times C. That is the cosine of A. So A will equal the inverse cosine of all of this. So I'll just bring my answer down. 83.54 degrees. Okay, so now I know this angle here, 83.54 degrees. Once again, I think I will use the sine rule. It's a little bit quicker. So now I know an angle and its opposite side. I can use the sine rule to figure out angles B and C. So I'll just jump ahead to sine B equals sine A over A times B, because I bring this B over to here. Just to speed things up a bit, I know that sine B of all of this equals 0.8279 blah 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 which when I do the inverse sine of all of this will give me 55.89 degrees. 55.89 degrees. Once again, I can use sine rule to figure out this, or I can just use the rule that angles in a triangle add up to 180. Now we have both triangles complete, so I'll update my diagram once more. These angles all add up to 180 degrees. Right, now that's certainly an achieved process so far. The last bit for merit or excellence is to divide this into 4 sections of 400 meters squared each, or more. So how I'm going to do that first is I'm going to divide this triangle here to some point on here that I don't know, so that this region here is 400 meters and this one here is whatever's left. But first I need to make sure that I know this triangle here is at least 800 meters, because if it's not, then I can't cut it into 2 bits of 400 or more. Sine rule for area equals a half BC sine A. So if this is A, then that can be B and C there. It's just the 2 sides which join the angle. So that equals a half times 40 times 50 times sine 60. It's about 866 meters squared. So I know that I can break this into 2 triangles. It's just a case of how. Well, I'm going to say that this area here, this triangle here, will be and I don't know this side here, I'll make that 400 meters. Therefore, using the area rule, 400 equals a half side B times side C, which I don't know, times sine 60. Now I can rearrange this to give me 2 times 400 divided by 50 times sine 60 equals C. All I've done is rearrange this equation to leave C on its own. If you don't know how I did that, I recommend you pause and do that step on your own. So that leaves me with the answer side C equals 18.48 meters. So that's this distance here. That means that the rest of this distance, 21.452, will give me the remaining 466 meters. So here we've shown that we've got one triangle which is 400 meters squared, and another one which is 466. So to do the same for this triangle by dividing it into two separate triangles will give you a mirror. But if you want excellence, remember we have to make one of these regions not a triangle. So here's how I'm going to do it. I'm going to take this triangle, and you don't have to do it this way, this is just an example of how you can do it, and I'm going to take this angle, 40.57 degrees, and these two sides, and I'm going to make an isosceles triangle to there. Now I don't know how long this length is going to be, I don't know how long this length is going to be. I'll call them B and C, and I'll call this angle A. Now what I do know is that the rule for the area of a triangle is a half BC sine A. What I also know about an isosceles triangle is that sides B and C will be the same length. So I can change this to, if B is the same as C, half B squared sine A. I know the area of this triangle is going to be 400 meters again. A half B squared sine 40.57. Now I haven't checked that the whole triangle is over 800 meters. I'll just take that as a given because I know it is, but you would need to check that first. But in the interest of time, here we go. So a half B squared, because B and C are the same length, sine 40.57. That means that 2 times 400 divided by sine 40.57 equals B squared. That is my B squared. So B equals the square root of all of this. We'll overestimate. 35.1 meters. So that means my triangle here is 35.1 meters. 35.1 meters. This triangle, it has a side of 55 meters, so that leaves me with 19.9 meters. Another side, which is 10.73 meters, 36 meters, and angles of 83, now I know this region here is 400 meters squared. So I can work out this area here simply by working out the area of the whole triangle and subtracting 400 meters squared. I'll do that now. So the whole triangle is this region here. If that's angle A, then it's going to be a half B C sine A. 819 meters. So this region here will be since this is 400, this region is 419.7 meters or thereabouts, and it's a quadrilateral, it's not a triangle. So according to the question, the property would only be bought if it could be divided into 4 regions of 400 meters, 466 meters, 400 meters, and 419 meters where one of them was not a triangle. And here's the quadrilateral. And that's all you need to do for this problem.